This is Alberta Hemsley of Withrow International High School of Cincinnati Public Schools in Cincinnati, Ohio. Today we're going to look at density. Density is mass divided by volume. We're going to find mass using a 4-beam balance. The first thing we will do is zero in the balance. We move all of the weights to zero and make sure that it balances in at zero. Here's a small magnet. We put the magnet on the scale and then make sure that the scale zeroes in. The balance is balanced when it reaches 47.783. We'll call the mass in grams 47.783. We have the grams. Now we need to find the volume. This magnet has an odd shape that won't be easy to measure with a ruler. We're going to use a cylinder with water. We'll use a 50 milliliter cylinder, and we will read this value as 27.6. We put the magnet into the cylinder, and the new value is 38.0. Now we take the difference of the 2 milliliter values, and that will give us the volume of our little magnet. The volume of the magnet is 10.4 milliliters, and now we have our values for both mass and volume. We divide. Our calculator answer is 4.5 with a lot of decimals. We need to identify the correct number of significant figures. This is a multiplication or division problem, so our significant figures is determined by the piece that has the fewest sig figs. Our volume had only 3 significant figures, so our answer can only have 3. We need to round. We look at the fourth number, and that fourth number is 4, which is less than 5, so the number before it stays the same. So our final answer is going to be 4.59 with units grams per milliliter. Let's compare our value to the value for water. Water is 1.0 grams per milliliter. Does our answer make sense? Yes. This magnet would probably sink. All density values greater than 1 sink. Let's find the density of an empty box. This time, the volume will be in centimeters cubed, or cubic centimeters. Let's first weigh the box. This box weighs 30.850 grams. 30.850 grams. Now let's find the volume. We can use a ruler to measure this box, and we'll measure in 3 directions from one corner. The blue side measures 7.60. The green side measures 7.76. The purple or long side weighs 17.31. We'll find the volume of the box by multiplying the 3 sides together. That equals a little over 1,000 centimeters cubed. We take our mass and our volume numbers and divide. Because we're using a ruler, we can only have 3 significant figures. We'll look at our 4th significant figure, and because it's less than 5, we will keep the same number. The last number remains a 2. Our final answer to 3 significant figures is 0.0302 grams per centimeter cubed. Does this seem like a reasonable answer? Would it float high on water? And the answer is sure would. One last density. Let's use the same box, but this time let's put a bottle of aspirin inside. Density will be mass over volume, or grams over centimeters cubed. We'll use the same volume. 268 grams and 0.641. 268.641 grams. the volume is the same. We multiply the three sides together. 7.60 times 7.76 times 17.31, giving us that same large volume of over 1,000 centimeters cubed. We divide our mass by our volume. This time we still get a decimal, but the density is over 10 times greater. Because we were using a ruler, we are limited to 3 significant figures. The 3 stays the same, because the fourth significant figure is a 1, much less than 5. Our final answer will be 0.263 with units grams per centimeter cubed. And there you have it. Density equals mass divided by volume. Some densities will be grams per milliliter. Some densities will be grams per centimeter cubed. Density, mass per volume. Enjoy!